Now let's talk about how we can summarize and compute descriptive statistics for our data and our data frames. Say we have a data set that looks like this, and it's kind of messy, but if you want, you can take a few minutes to figure out how this is being structured. We have an index that's going to be named, and we also have some columns that are specified. When we run that, we can actually see the data looks like this. We have 1.4, 7.10 nan, 0.75 nan, negative 4.5 nan, and minus 1.3. If you ever want to specify a nan value in a dataset, you can actually call it np.nan. And this is actually the representation of a nan value in NumPy. So in case you ever need to do that, that's how you do it. We can actually just say, what is the median of this data frame? And what it will do is it will go column by column, and it will calculate the median for that particular data frame. And so you can see the median of column 1 is 1.4, and the median of column 2 is minus 2.9. We could then say, well, give me a sum along the column axis. So basically it's going to create a sum from each of these basically rows here, and you can see that it's summing along each row. And it will actually give you here, you can see the sums here. This is a little bit odd, but you could get a row total sum. Typically, you wouldn't want to go across rows, but it depends on how your data is actually structured. You could also say df.mean. It's very similar to median, except it's getting the mean, and it will give you a column by column mean. Better yet, you can do it all with one single thing, and you can say df.describe. df.describe will actually run many different descriptive statistics for you. It will count the number of columns. It will calculate the mean for you. It will calculate the standard deviation, the minimum value, what we call the interquartile range, if you know anything about statistics, the 25%, the 50%, and the 75th percentiles, and also the maximum values. So you can see a lot of information about your data sets just by looking at df.describe. I can run it again here, and we can see pd.series, and we can say object.describe, and we can run that. And we can see that there are actually now, on a series, it looks a little bit different than a data frame. So we can see that it will give us count, the number of unique values, the top values, and the frequency. But of course, this actual object is not actual numbers, right? So we can see that the actual data is just text. So you could actually run df.describe on a pandas series as well if it was text only. So in a data frame, you might want to call just the one column and do df.describe on the one column. So this would look something like this. And it will actually give you very similar data to this, but it will actually calculate it just on that one particular column. So depending on what you want to do, there's many different flexible ways to use these methods. Also, part of running descriptive statistics and describing your data is understanding the unique values, the value counts, and whether something is in or not in your data frame or your series. We can actually use the .unique method to tell the unique values in a particular series or even a data frame. So we can see here we have C, A, D, A, A, B, B, C, C, which are quite a lot of actually duplicated values. When we say object.unique, it will give us an array of unique values. We could then save those unique values if we would like to, that you could actually use later. We could also do something like value counts. So if I do object.valueCounts on that series, it will actually count the frequency of usage for each of those things. So we could actually make something like maybe a bar plot or something like this, which I'll show you soon, and you can actually be able to do that. pd.valueCounts can actually be used as well, and you just have to pass through the object values, and you can actually say, sort yes or no. This is actually a little bit easier to use because it's shorter to write, obviously, and it basically gives you what you want, but this gives you some more control over sorting and stuff like that. It's the same thing, though. It'll return the same object. You can figure out if something is in something else by actually just asking. So if is B and C in this object, and it will return a Boolean series of true and false values. We could then save that Boolean series to what's called a mask, like I mentioned before, and then we can see the mask is now like this. What I can then do is call that mask on the series, and it will only return the data from the series that's actually true. So you can see here it's actually going to return 0, 5, 6, 7, and 8, which you can see here will return. This is another way to actually filter and figure out if something is inside of that, some other object, like a series. Typically, this will be done on a series object. Okay, on the next video, we're going to put it all together and kind of use all the different pieces that we learned in today's videos into one kind of simple demonstration of what we can do with this data.